Now let's look at the other special right triangle we worked with called a 30, 60, 90 degree right triangle. And we went over different scenarios in class of how they can picture it and mark it so that we would know which special right rules to use. Here are some more pictures of more triangles that would use the 30, 60, 90 rule. And to start the process, we talked about there's 3 different lengths of sides for this kind of right triangle, and once we get the lengths, it still would be able to be plugged into Pythagorean theorem and work to show we did our work correctly. But now, since the lengths are different, we have a small, a medium, and a large. We need to remember that if we start with something called S and double it, this one is 100% bigger. But if we start with something and multiply it times the square root of 3, and I'm pulling up my calculator right now, I'm going to do control square root 3, enter. It's 1.73205. So I'll put up here so we know. Square root of 3 equals 1.73205. It means this leg I'm calling the long leg. It's not the longest. It's not the hypotenuse. Hypotenuse is 100% bigger than the shortest leg, but the one I call the long leg is 73% bigger. So that's how we get our sizes. But we're just going to apply the proportion because we don't want to mess with all those decimals. It's so much easier to say this is 2. If I double it to get my hypotenuse, I have 4. If I just need it 73% bigger, I'm just going to put 2 times the square root of 3. Okay. Here, if my long leg is represented by 6 times the square root of 3, that means S, my short leg is S, has to be 6. If I double it to get my hypotenuse, I have 12. If my hypotenuse equals 2S, means I can divide it by 2 and know my short leg is 7. And to get my long leg, the sides in the middle, 7 square roots of 3. Everyone did really good in class. They looked at this one, they go, oh, that means your short leg is 8. And when I double it, my longest leg, my hypotenuse is 16. It's a little different here because I had to deal with fractions or decimals, but same principle. If I divide 15 by 2, I told you in class, I tend to keep my answers in fraction form to leave me the ability to cancel between my numerator and denominator if numbers are bigger. But people who wanted to write 7.5, we said, okay, I know y'all like decimals better. That meant this answer was either 15 over 2 times the square root of 3, or for those who like decimals, it would be equivalent to say this. But typically you'll see things in fraction form. Then I'm going to do another highlighter color coming through the page to remind us the top part were the real easy, straightforward ones to gain practice and confidence. And now we'll work a little bit deeper with our radical rules. So if one leg is 13 square times 2 and I want my largest, I want to double it, that would take 13 times square root of 3 over 2 times 2, which is the same as 2 over 1. The 2 in the numerator would cancel with the 2 in the denominator, and the hypotenuse would be 13 square roots of 3. Looks like that went a little bit off camera, so let me pull it up. That was 13 square root of 3 over 2. We had to double it, but that 2 canceled with this 2, ended up giving us this answer. If we'd wanted to take our 13 square root of 3 over 2 as our S value and multiply it times square root of 3, that's where we get 13 times the square root of 3 squared. Anything times itself is squared. We still have the 2 in the denominator, so we end up with 13 times 13 over 2, and that's going to be, 13 times 3. That's a 3 of 2. It's going to give us 39 over 2. And in class, we said we could also call it 19.5. I don't have room to write it, but I'm going to clean up that copy while we move to the next one. So this was Square root of 3 squared was just 3. And when that dries, I'll get a 3 back in there. So we can see 3 times 13 is 39. Okay, while that dries, I'll try and remember to come back to it. Let's look at this one. The hypotenuse is 18. We take half of it to get the short leg, and we do the short leg times square root of 3 to get the long leg. If the short leg is 7 square roots of 2, we have to double it to get the hypotenuse. That's 14 square roots of 2. To get the long leg, we do 7 square roots of 2 times the square root of 3. That means square root of 2 times square root of 3 is square root of 6. This is one that's tricky, just like on the 45, 45, 90. When the long leg, which equals s square roots of 3, way back up at the top, the long leg always equals s square roots of 3, we have to rationalize the denominator. So I'm going to take the shortcut first, and I'll show you the math. I know to rationalize this denominator, I have to say 4 times the square root of 3 over 3 is my answer. And to double that, I would get 8 times the square root of 3 over 3. So let me walk through the math. We said if 4 was the long leg, and the long leg always equals s times the square root of 3. Last year in algebra, we would have divided both sides by the square root of 3. This would cancel, and I'd have s equals 4 square root 3. But radical rules say you can never have a radical sign in the denominator, so that's when I've got to multiply by something that will get it out of there, and I called it ugly 1. I'm going to get a different color. I'm going to kind of make a one around this. Okay, there's my 1. That would leave me with 4 times the square root of 3 for the numerator, but square root of 3 squared in the denominator. Well, we know a square root, that radical sign, and a square will cancel each other, and that's why our final answer ended up being 4 times the square root of 3 over 3. It's too much for me to expect you to show me all that. If you learn the shortcut the rest of us have, then you could do what I showed you here and just write 4 times square root of 3 over 3 and have your answer, and then double it to get your hypotenuse.